Hi my dear children, how are you? Good morning to you all. Today we are coming with Chemical Kinetics. This is Suresh, Faculty of Chemistry from Sri Chaitanya Academy, NEET YouTube channel. How are you all? Fine. Here in the Chemical Kinetics, you are going to get one question from the NEET examination for sure. And along with the boards, we are talking about the Chemical Kinetics for the NEET examination. You know, for the Chemical Kinetics boards, definitely you are going to get 10 marks from it. Right? So get ready, board के साथ NEET preparation, and this is the right time to enjoy this one shot session with chemical kinetics. In all topics from the chemical kinetics will be closed in today's session. Take a pen and paper and join with us. Hi Anuj Gope, how are you all? And in the chemical kinetics, the topics which are very important: order, molecularity, rate of reaction, average rate, instantaneous rate, order, molecularity, and different orders, their integrated rate equations and various graphs, and experimental determination of order, and Arrhenius theory, temperature effect, and collision theory. Everything in one shot. Get ready, and everything will be given to you. So those who are online, please like this session, share with your friends, and subscribe to Sri Chaitanya Academy, NEET Academy. Right? G mains as on 23rd January, first shift. Kaise kiya tu? Of course, in this particular channel, it is meant for NEET, but also great JEE preparing students are also joining, because chemistry usme common rahega, hai na? Those students who are online, come on, in chemical kinetics, right from scratch level. If you say I don't know anything, you are going to learn many things in today's session. And don't lose the energy and tempo. Take a pen and paper, join with us. Hi. हो गया मेरे पेपर केमिस्ट्री मुझे मॉडरेट लग रहे थे. वेरी गुड. स्टेटमेंट बेस्ड क्वेश्चंस आर वेरी इंपॉर्टेंट, ताकि एनटीए इज mainly focusing on statement based questions. It happened in the NEET exam, it happened in the JEE examination. I am expecting you to give in the आगे आने वाले का NEET examination भी ऐसे होता है. Hi Surya Pandit, how are you? You're back. Great. God bless you all, my dear students. Come on. In chemical kinetics, what are the things we are going to see? Chemistry is always concerned about the change, physical change and the chemical change, right? By means of a chemical reaction. Somebody ask you, what is chemistry? Chemistry is a study of chemical reactions. Chemical reaction में क्या होता है? Reactant, product बदलते. There is a change. And one student is joking in the class when I was asking what is chemistry. He's given a weird answer that chemistry, sir, chemistry is a collection of all exceptions. I was astonished to hear that. Do you? Good morning. So 24/1/2026. अरे बेटा, जो JEE एग्जामिनेशन कोरिलेशन का हिसाब से नीट एग्जामिनेशन भी थोड़ा सा जटिल आने का संभावना है बेटा. According to JEE 2026 January session, I am expecting, with my experience, you are going to get an impact in the NEET examination. So get ready to face it. It is a hard warning, bachcho, and no worries. I am not creating a fear. I am motivating you. The questions will come in such a way that you will be tested your application ability. Right? Be confident. Stick to the NCERT. All students, take care. Come on. So physical chemistry, जहां पर न्यूमेरिकल आता है ना, लोगों मानते हैं फिजिकल केमिस्ट्री है, बट फिजिकल केमिस्ट्री हैज 3 मेजर टॉपिक्स एज ए कोर, एंड केमिकल इक्विलिब्रियम, थर्मोडायनामिक्स एंड केमिकल काइनेटिक्स. मैंने केमिस्ट्री अच्छा किया, वेरी गुड, कंग्रेचुलेशंस. सो thermodynamics basically talks about the feasibility of a reaction, bachcho. And a chemical equilibrium, it talks about extent of reaction. Surya Pandit, right? Ha, very good, thank you. Surya Pratap, thank you. Chemical kinetics talks about the speed of a reaction. So chemistry is a study of chemical reaction. Chemical physical aspect of a chemical reaction is the feasibility, extent and the speed. आज हम चर्चा करने वाले हैं speed of a reaction. And in the speed of a reaction, you see, there are various means to say the speed of reaction. The rate and the mechanism is based on chemical kinetics. When you study organic chemistry, total organic chemistry is putting arrow here and there is called mechanism. You feel that arrow marks and feel that mechanism is so difficult. No, it is not difficult, it is easy. It is the base of the mechanism is of chemical kinetics, बच्चों. Paper 1 का अच्छा लग रहा है. So along with the feasibility, the chemical kinetics talks about the rate. What is the meaning of a rate? Change with respect to time. Here what is changing? Concentration is changing, reactant ka and product ka. And we see thermodynamics tells only about the feasibility of a reaction, bachcho. And you know, however, chemical kinetics tells about the speed of a reaction, how fast the reaction is going there. Bilkul. Third shift to paper 1 ka paper by dekh liye. Okay. So let us discuss about chemical kinetics here, and I am going to inculcate some concept right now, which is there in the JEE paper also, and you are going to prepare boards as well as your NEET examination, right? So you can use the chart box for betterment of the class. Okay. Now you see rate of a chemical reaction. Some chemical reactions are rapid. आपका जैसे the burning of a butane, LPG, it is very fast reaction. Explosion of a bomb, it is very fast reaction. Certain reactions you see, some reactions proceed with moderate speed, like sucrose is converted into glucose and fructose. And you can measure the rate here experimentally, decomposition of hydrogen peroxide. But you can't measure the rate here because the time takes to complete this reaction is very small. Experiment mein nahi chalta. And this is a moderate reaction, students. In the moderate reaction, you can measure the concentration, you can measure the time. Experimentally, it is feasible. कल practical है ना? Is moderate reaction के हिसाब से question आने की संभावना है. Okay. Decomposition of ethyl acetate pseudo-first-order reaction है. ये भी आज चर्चा कर सकता हूँ मैं. And also some reactions are so pretty slow, pretty well slow. Rusting of an iron, very slow. And chemical kinetics का जो what is that scope है, it is not applicable for very slow reaction, it is not applicable for very fast reaction, rather it is applicable for moderate reaction. You can use the chemical kinetics here. Not very fast reaction, they are called as instantaneous reactions, and very slow reactions. Okay, no problem. Anuj, no problem. Let us continue and let us see a rate. In this rate of a chemical reaction, rate is a change, bachcho. A change किस तरह का change है? There is a change in the concentration, or there is a change in the pressure, there is a change in the active mass with respect to time. It is known as the chemical reaction rate. And this rate can be expressed as, it is expressed as, you can say, rate of decrease in the concentration of the reactant. As reactant gives rise to the product, reactants gets disappeared, so rate of disappearance of reactant, and the product is generating, so products are appearing, so rate of appearance of the product, you know. Okay, Anuj, Surya, Pandit, those students who are online, please like the session and talk to me, and we are going to explore the subject in such a way that there is no break today, and take a pen and paper and write and learn the things along with me. Okay, beta? And we are going to discuss this rate. In the various formats. So, rate of a chemical reaction. For a gaseous reaction at constant temperature, there is a change in the pressure, isn't it? So, the concentration could be a partial pressure of the species. So, I want to say it is concept of active mass. What is the meaning of active mass? This can be concentration, that is in mole per liter, or in terms of partial pressure, It could be atmospheres or mmHg, or it could be and mole fraction as well. Anything can be possible. Actually, this active mass is the concept you learned in a chemical equilibrium, isn't it, बच्चों? ओनली स्टडी सर बोर्ड एग्जाम के लिए आज हम सेशन बना रहे, ये बोर्ड के इस्तेमाल कर सकते सीधा, and maximum it is going for the board, and I am going to take some points in terms of NEET examination as well, right? Only study, right? And rate is expressed as the rate of change in partial pressure of a reactant or the product. है ना बेटा? So I want to say rate means the change, okay, and you can say change anything if A gives rise to B with respect to time. ये mantra total chemical equilibrium as well as chemical kinetics, and these are cousins. Chemical equilibrium and chemical kinetics, these two are cousins. It is extended version. And chemical equilibrium talks about extent of a reaction, and chemical kinetics talks about the rate of a reaction. Rate means speed of a reaction, right, Bacha? And here the types of rates. Here average rate and instantaneous rate. And I want to tell you a long story in a short. Average rate is the rate in an interval of time, and instantaneous rate is a rate, the rate at that instant of time. So let's see here the average rate and the instantaneous rate. The reactant gives rise to P, product. R stands for reactant, P stands for the product. So the average rate, the total change in the concentration and the time interval is taken. So that is C stands for concentration, initial, final minus initial upon time final minus initial. We can say this is del C by del T. I am telling you today's session we are talking in terms of boards as well as NEET, and this is the period students talk about only boards. This time is so valuable, so you focus on the textbook and the board, and NEET is slowly detaching for a month or 45 days, but in the next 90 days you are going to have your NEET examination. So the moment you complete your board examination, NEET examination का turbulence ज़्यादा होगा, pressure बढ़ता है. So we schedule this kind of sessions in such a way that you won't be having any pressure, because एक बार बोर्ड का रिवीजन चलता है NEET examination के साथ. Stay tuned, please like the session, share with your friends right now, and let us talk about this average rate. So, and if the reactant gives rise to the product, in terms of the product, in terms of the reactant, there is a decrease in the concentration of reactant upon time taken for it. That is, average rate means the rate of a reaction at a given interval of time. Reactant concentration final minus reactant concentration initial upon the time final minus time initial. So R2 minus R1 upon T2 minus T1. That is given as product, you can say, rate of appearance of product. As a reactant is decreasing, product concentration is increasing. Only JEE, chemical kinetics is a topic which is there in the JEE as well as NEET. I don't know how many of you are aspiring for JEE, but because the popularity with me in the YouTube channel, guys, those who are in the JEE channel also joining with us, and welcome, and the common topic hai and the concept bhi wahi hai, and you please enjoy. Just you are going to see the different title in the question paper. Model hi same hoga. Okay beta, and you can see in terms of the product. So P2 minus P1 upon T2 minus T1. So the increase in the concentration of product with the time taken, that is the average rate of a reaction. Abhi Madhya Pradesh aaye aap. So during a reaction, the concentration of the reactant decreases and the product concentration is increased. I want to say here is the concentration of the reactant and the time, it is decreased. And if you talk about the concentration of the product with the time, it is going to be increased. Are you getting on? Down and up. And you can see here, the rate is defined as a measure, so that is always positive. That's why rate is taken as a magnitude. But in terms of reactant, the rate is shown with a negative. It indicates that rate of a reaction, concentration of the reactant is decreased. It doesn't mean that rate is a negative. Magnitude lena padta. You are from Pakistan, welcome. Okay, and for the product it is the same. And reactant के हिसाब से negative लेना है, ये काफी important है. I want to say negative value cannot be. Okay, 1 mole of reactant gives rise to 1 mole of the product. ऐसे चलता है, rate of disappearance of reactant is equal to rate of appearance of product. And average rate T R average is given as minus del R by del T is equal to plus del P by del T. बच्चों, what this minus indicates? This minus indicates there is a decrease in the concentration of reactant. Okay, मेरा total मिलेगा 144, percentage भी, percentile is based on how much, how many students we are preparing and attending. Okay, so abhi we cannot talk about that. And in terms of here, you can see the concentration of the rate versus time. You can see the reactant, initially the reactant concentration is decreasing, and when the time T1, the reaction concentration is going to be R1. At the time T2, it is going to be R2, and this is said to be del R, and this is said to be del T, right? And this is said to be a slope that is going to rate average. This is what I want to say, minus del R by del T. Understood, bachcho? Clear? And at the same time, if the product concentration is increased at a time T1, and the product concentration is going to be P1, and T2, product concentration is going to be P2, bachcho. You see, this is going to be del P, and it is going to be del T, and the concentration rate with respect to the product is going to be del P by del T. Yeah, definitely you can get it, beta. Anuj Gupe, you will get it. And you know, that is given as average rate is the rate at in a given interval of time. So you are going to see this is the slope, na? And this slope is secant joining 2 points, isn't it? Isn't it? Yes. Looking at the slope for the entire chapter is very important. Chemical kinetics देखना के कैसे. You are going to get so many graphs. There are 10 graphs I just want to show in today's class. Get ready. And I want to say instantaneous rate. In the instantaneous rate, when the average rate, the time limit tends to 0, average rate becomes an instantaneous rate. The rate at that particular instant of time is going to be dC by dt. I want to say dr by dt is equal to dp by dt, and you can see this is the instantaneous rate. So rate of disappearance of the reactant at that instant of time is equal to rate of appearance of the product at that instant of time. When you say this is the average rate, no? Take a tangent, and this is the point dC by dt, and this is the point dC by dt. This is what is called as, this tangent is important to say the average rate becomes the instantaneous rate. Second who? क्यों लिया? अरे you are an IT student, you know that then the instantaneous rate of reaction can be determined by drawing a tangent at the time of concentration versus time, right? and for the negative slope and the positive slope. You see, as a positive slope indicates the rate of appearance of the product. The negative slope indicates the rate of disappearance of the reactant. है ना बेटा? And you can use the different graphs. एक एक ग्राफ में बना के रखा हूं मैं. This is what? As the rate of reaction is decreasing with respect to time. If this is the two terms, time 1, time 2, and this is called average rate, and if you take a slope here, the tangent you can say, that is minus dr by dt is going to be negative slope, right? This is the difference between average rate and instantaneous rate. समझ में आ रहा है क्या? Satyam the Great, hi, very good. Please like the session, only study. Please like the session, bachcho, and those who are online, please like the session. And at the same time, if the product concentration is increased, relation between the rate of different species involved in the reaction, this is very important, bachcho. This is very important. 145 आ रहा है, 180 को कोशिश करो सेशन 2 में. ओके बेटा, राइट. हाँ, बोर्ड भी है, इसी के कारण आई एम टेकिंग द सेशंस लाइक दिस राइट नाउ. Everybody, with respect to of your medical or engineering or IIT or whatever, you have chemical kinetics, right? And NCERT based total chemical kinetics 1 session में जा रहा हूँ. ठीक है बेटा, चलो. Definitely, Sachyam, come on. Let us see here. Example, N2 plus 3H2 gives rise to NH3. Here you can see the stoichiometric number जो है ना 1, 3 and 1 by 2. And these numbers are written as a fraction. 1 become 1 by 1, 2 become 1 by 2 and 3 become 1 by 3. Okay? No, Anuj, that kind of discussions are not entertained here. Rate with respect to nitrogen is going to be minus d N2 by dt. Rate with respect to hydrogen is going to be minus dH2 by dt. Rate with respect to NH3 is minus d NH3 by dt. Here these are all correct rate expressions, however they are not equal, right? Because ये coefficients के हिसाब से, right? So what I want to do here, I want to take rate of consumption of nitrogen is equal to 1 by 3 of the rate of consumption of hydrogen, and it is going to be 1 by 2 the rate of formation of NH3. That is the reason why I just want to say rate is equal to minus dN2 by dt is equal, जो भी number है ना, right, minus 1 by 3 dH2 by dt is equal to plus 1 by 2 d NH3 by dt. And everybody can write this, but उसमें क्या देखना चाहता हूँ, here this is the term, this is the term, and this is the term. The blue color circles you can see, that is said to be rate of disappearance of nitrogen, rate of disappearance of hydrogen, rate of appearance of ammonia. Fine? Clear? And 1 mole of nitrogen react with 3 moles of hydrogen to produce 2 moles of ammonia. इसी के कारण मैं इसका फ्रैक्शन में लगा दिया. That is the simplest technique. जो नंबर है ना, these numbers you just make it as a fraction. Are you getting or no? That is the simplest way you can sing. बच्चों समझ में आ रहे क्या? Come on. फ्रैक्शन में आया क्यों लिखा? क्योंकि 1 mole disappeared, at the same time 3 moles is disappearing. So rate is going to be 1/3 of this, no? isn't it? Fine. So, this is the confusion number 1. This is the confusion number 1. I think your confusion is cleared. Now, by convention, the rate of a reaction is always expressed as overall rate of a reaction. Clear, that's good. So, by dividing individual rate with their stoichiometric numbers. So, N2, 3H2, 2NH3, you are going to write like this. With respect to nitrogen, with respect to hydrogen, with respect to NH3. But the overall is going to be, it is 1/3, it is going to be 1/2. Now, this slide can give you the clear picture about how the rate changes. Hope you like this. Now, you can say A moles of A, B moles of B, C moles of C, D moles of D. Now, with this I can say that average rate is going to be minus 1 by A is equal to minus 1 by B. So, instantaneous rate minus 1 by A dA by dt, minus 1 by B dB by dt is equal to minus plus 1 by C dC by dt is equal to plus 1 by D dd by dt. So, this is the simplest way. कहीं भी इस्तेमाल करो चलेगा, ठीक है. Fine. Okay. Now, the value of rate reaction is independent on the stoichiometric coefficients, substances involved in the reaction. That is a very important noteworthy point. When you learn something, you try to learn what should be done, what should not be done. Then automatically you will understand, right? And however, the rate with respect to any species is dependent of the stoichiometric coefficient. And you can see here the dimension. When you say concentration with the time, simply it is said to be mole per liter upon, simply you can say second. So, मिलके mole liter inverse second inverse, isn't it? और SI units में you are going to see in the SI units बच्चों. This is in the SI units, mole dm power minus 3 second inverse, है ना? So, sometimes this kind of things may confuse you. You just focus on SI units as well, बच्चों. And moving ahead, बच्चों, for a gaseous reaction, you have to see in the change in the pressure. The change in the pressure you can measure in atmospheres, bars, mmHg, whatever. So, unit of the equation is going to be atmosphere second inverse. Any dimension of pressure second inverse. mmHg and second inverse. ये भी एक होगा. And you can see that one more. So, factors affecting the rate of a reaction. We are more focused here. All these 5 factors I will tell you. By looking at the reaction, we can say. First, nature of the reactant, first of all. उसमें लिखा नहीं, I will tell you. The reactions involved by ionic compounds and the reactions involved by covalent compounds. The reactions involved by ionic compounds in the aqueous solutions are fast as compared to the covalent compounds. है ना? Right. One more. If the reactant are gaseous or liquids or the solids, the rate of reaction gases is faster than the liquids, faster than the solids in general. And effect of concentration, as concentration बढ़ते जाते हैं, rate of a reaction बढ़ते जाता है. It depends on the order of a reaction. Simply, I want to generalize this. Rate of a reaction is directly proportional to concentration of the reactant to the power n. That is, n is said to be order. We are going to deeply investigate about the value of n, that is an order. Ionic compound or covalent compound count. Right. And effect of nature of reactant and the product, as I mentioned. So the reactions which involves less number of bond breaking and bond breaking are fast, and the reactions that involve more number of bond breaking and bond making are slow. Effect of pressure, that is also the same, and depends on the order of reaction. Rate is directly proportional to pressure to the power n, depending upon the order of a reaction. Here effect of टेम्परेचर कोशेंट के हिसाब से बोल सकता हूँ, Arrhenius theory and collision theory के हिसाब से बोल सकता हूँ. अरे your grade 11 12 you will be knowing any salt is ionic, any other thing is going to be covalent, है ना. Only study. अरे Ziegler-Natta, will discuss about the Ziegler-Natta catalyst is as well. Okay. Okay, bachcho, effect of catalyst, we learn about the catalyst and positive catalyst and negative catalyst. Everything we'll discuss in today's class in this one shot series. Bachcho, you can see here. So, effect of concentration. Bachcho, here the rate of the reaction is often found to be proportional to the concentration of the reactants raised to a power, some power. So, rate is directly proportional to, let us say, concentration to the power n, some number. What is that? What is that? n value hota hai kya? That's pretty well, it is going to be order, 0 order, first order, second order. We will discuss about second order. 0 order और first order NCERT के हिसाब से काफ़ी important है. ठीक है बच्चों. And rate law, so instantaneous rate, you can see it is an equation that expresses the rate of a reaction as a function of the concentration. Okay. So, rate is directly proportional to the concentration of the to the power order, that is called rate law. Okay. And rate is equal to K, concentration to the power order. And what is that order? We are going to focus most about the order in today's class. नहीं, ये साल में है ना. हमें जेई पेपर डिस्कशन ये चैनल में आए थे, आप नहीं देखे क्या? Anuj, function of concentration means the rate of a reaction depends, how it depends on the concentration of the reactant. Okay. And we take that function and we mathematically operate that. And you can see, let us say here, let us say here, A moles of A plus B moles of B gives us C moles of C and D moles of D, right? So, the rate of reaction is equal to, directly proportional to the concentration of A to the power X and B to the power B. हर shift में थे मैं. Anush, let us focus here. Students are waiting to some context here. And rate of reaction is equal to K, A to the power X and B to the power Y. So, what is this X and Y? And K is a rate constant. Here A, B, C, D, small a, B, C, D are said to be stoichiometric coefficients. We are not going to use this. If you use this stoichiometric coefficient directly into the rate law, it is wrong. So, here X and Y may or may not be equal to small a and small b. Most of the cases it may be equal, but X and Y, X is not exactly equal to A, Y is not exactly equal to B. So that is the confusion number 2 when a student starts studying chemical kinetics. So come out, I am going to unveil what is this x and y. And this x and y is said to be, x is the order with respect to A and y is the order with respect to Y. Right? So each term raised to the some power that is said to be order, and the overall order is going to be x plus y, and this order, which may or may not be the same as the stoichiometric coefficients. These are the noteworthy points you need to know, and those students, please understand the concept. If you have any conceptual doubts, please let me know in the chat box so that we can have a nice discussion about that. Fine. Moving ahead. So it can only be established in experiments. X and Y is established in experiments. So rate reactant gives rise to the product, and it may different from the same reaction under different conditions. Yes, X and Y is the variable if conditions are changed in most of the cases. So the rate of a reaction is equal to K reactant concentration to the power order, and thus reactant concentration to the power order, and this is called rate law. X और Y क्या एग्जाम समझ नहीं आए, एक एक्सपेरिमेंट के हिसाब से आप निकालना है बेटा. अभी आप चर्चा करने वाला है एक्स एंड वाई होता है क्या, कैसे पकड़ना है. ओके, ठीक है बेटा, डोंट वरी. सो प्लीज लाइक द सेशन एंड rate constant. We know that rate is equal to K reactant to the power order. This order could be either X or Y or X plus Y, and K is said to be rate constant. This rate constant tells you, the value can tells you how speed the reaction is going on. इसका dimension भी होता है. So it is the rate of reaction when the concentration is taken as unity. जब reactant का concentration 1 mole per liter, molarity 1 होगा, तभी ये K is equal to rate constant. Is also known as specific rate constant or specific rate, where N is the order. So you can say rate now is equal to K reactant concentration to the power N. So K is equal to rate and reactant concentration to the power N. You can just write it here. Rate is equal to mole liter inverse now, mole liter inverse and second inverse ना, इसका मोल लीटर इनवर्स टू दी पावर n. सब मिल के आपको n निकाल सकते हैं, n का हिसाब से होगा. ठीक है. एंड यू कैन से यूनिट ऑफ द रेट कांस्टेंट, यूनिट ऑफ द कॉन्सेंट्रेशन इज मोल पर लीटर, यूनिट ऑफ द रेट कॉन्सेंट्रेशन टाइम इनवर्स, and unit of K mole 1 minus n and liter n minus 1 second inverse. So जो भी ये n का हिसाब से, n could be 0 or 1 or 2 or can be fractional as well, sometimes negative also, and we'll discuss more deep into the details about the rate here. And you can say A moles of A, B moles of B, C moles of C, मिलके products दे रहा हूँ. So experimentally rate of a reaction is directly proportional to A to the power P, B to the power Q and C to the power R. So PQ or experimentally determine करता पड़ता, and you can say order P is the order with respect to A बच्चों, and Q is the order with respect to B, and R is the order with respect to C, and P plus Q plus R is said to be overall order, overall order. Fine. And so PQR sum of the exponents P, Q, R is said to be the overall reaction order, and order of a reaction is the sum of the powers, and you can see, so or a rate is directly proportional to a to the power p, b to the power q, and c to the power c, and they are multiples. P may or may not be equal to a, as I mentioned, and q may not be equal to b, or may not be equal to c. Sometimes it could be same. Say an example here. So the order of a reaction can be a 0, or it can be a whole number, or it could be fractional also. Sometimes it is negative and greater than 3 as well. And sometimes you say it is maximum 3 hoga, but sometimes it can be 3.5 as well. It can be fractional, it can be it even can be a negative with respect to a particular reactant. But एक चीज है, the overall order can never be negative. That is a very important, can never be negative. ठीक है? And say an example, N2O5 gives rise NO2 and O2 2 4 1. Rate law is given as K N2O5. यहाँ पर 1 दे दिया ना, but here 2 दे दिया. It is different. अरे one thing I'll tell you बच्चों, first of all, by looking at this reaction, please don't write rate law. You cannot, but you don't know. This is the behavior of this reaction. It is determined how it is behaving experimentally. ये experimental के हिसाब से देना पड़ता. Overall order of a reaction is one only, first order reaction. It is weird and surprising. इसमें लेना कैसे है? First of all, take something from our mind by looking at that chemical reaction. Don't write rate law. So now the problem is solved. The problem is started when you start writing rate law. Who asked you to write? There are certain ways to write this, and we are going to discuss it like 5Br minus plus BrO3 minus plus 6H plus gives rise Br2 and H2O. Experimentally, it is observed that rate law Br minus to the power 1, BrO3 minus to the power 1, and H plus a square. Overall order is going to be 1 plus 1 plus 2. That is going to be 4. It is experimentally. हाँ याद आ रहा है क्या? Don't write. यहाँ पे जो numbers है ना वो अलग है, वो अलग है, लेकिन ये जो numbers है ना experimentally determine करके ये निकाल दिया. Please don't by heart this. Okay, right. And also order of a reaction, a balanced equation does not necessarily give a true picture of how the reaction takes place. Just it is according to law and mass conservation, the reaction is balanced. But relay, a reaction gets completed in one step. The reaction may not complete in one step. There are two types of reactions has been classified: elementary reaction and complex reaction. So the reaction involves only in a single step is said to be elementary step. Response sheet ये अगले हफ्ते में आने का संभावना है बेटा. And the sum of stoichiometric coefficients is equal to overall order of a reaction बच्चों. ठीक है? Very good. Fine, and we can see H2 plus I2 gives rise to HI. And the rate is going to be KH2 and I2. And the overall reaction, this time we are lucky, वो जो number है ना, वो number के हिसाब से जा रहे हैं. 1 plus 1 is equal to 2. And reactions are single step reactions are called elementary reactions, and multiple step reactions are called complex reaction. So जो elementary reaction है ना, एक ही step में जाता है. This is an example of elementary reaction. समझ में आ रहा है क्या? And for a complex reaction, the reaction involves more than one step. One of my students is saying in the chat box, he is correct, absolutely तालिया आपका. And the order is experimentally calculated for the complex reaction, right? For example, 2NO plus 2H2 gives us N2 plus H2. and different probability calculate. So there are step 1, step 2, step 3. Step 1, NO is going to give this N2O2 hypothetically, and N2O2 H2 पकड़ के N2O बनेगा laughing gas and H2O, and N2O फिर H2 बन के N2 and H2O बनेगा. There are 3 genuine steps you can say. You may isolate, you may not be isolate in the middle of the compounds that are intermediate compounds that are formed, that is N2O2 and N2O, right? The overall rate of a reaction is said to be N2O square and H2O. Order is going to be 2 plus 1 is going to be 3. 2 plus 1 is going to be 3 here. So I want to say the overall order is going to be रेट लॉ के हिसाब से कौन सा लिखना, ये तीनों स्टेप में जो भी स्लोएस्ट स्टेप है वो स्टेप रेट डिटरमाइनिंग स्टेप होगा. ये रेट डिटरमाइनिंग स्टेप के लिए आप ऑर्डर दे सकते हैं. सो इट इज गोइंग टू बी हियर, आई वांट टू से 2 plus 1 is going to be 3 is the order of a reaction. थर्ड स्टेप में रिएक्टेंट का ऑक्सीजन कहाँ गया, N2O है ना, H2O बन गया ना. फाइन, दैट इज वेरी इंपॉर्टेंट. क्लियर बेटा? Yes, that's perfect here. Methods to analyze the rate of reaction, we have 4 different methods. 4 different methods. ठीक है? And initial rate method, integrated rate law method, we are going to see the graphical method, and unit and dimensional analysis, 4 different methods. Okay, so let us discuss these methods. Get ready. And graphical method is also very important. We are going to see so many things in this initial rate method. ठीक है बेटा, initial rate method में क्या होगा? Let's say मान के चलो ये moles of A plus B moles of B plus C moles of C gives us some useless products, right? इसमें ये तीनों में देखो N2O2 is formed, N2O2 is consumed. N2O is formed, N2O is consumed. Okay. Now you are going to see water is formed, N2 is formed. Understand? And H2 is formed as, you can say, H2O. So that you are going to remove that H2O. Now we are going to see only one. Okay, उसमें slowest step पकड़ के आपका rate निकाल दिया. So let us talk about the initial rate method. This method actually, this method is actually finding the initial rate experimentally better. Okay, so by taking known concentration of the reactant rates, when you conduct the experiment, how much reactant A, how much reactant B, how much reactant C is taken. So keeping one reactant as a constant, and second दूसरा reactant का concentration variable करके initial rate calculate करना पड़ता. And let us say here it is an instantaneous rate, you just calculate at the time. Understand? And by taking the various involving comparison of different initial rate of a reaction better, and by varying the concentration of one of the reactants while the other reactant kept constant. So I want to keep the concentration of A is changed, and by keeping the concentration of B and C as the same as before, so that आप P का value निकाल सकते हैं by comparing the different rate equations. Are you getting or not? That is a important question in the NCERTs also. It is given by looking at the rate values, you can say N value. ठीक है बेटा? And we can see, so compare rate 1 at the some time period T1 and rate and at the time period T2, and you can calculate the P value. So the value of P can be calculated by measuring this A0, A2, A1, A3 like that. That is called initial rate method. So following the same method for the Q and R for the B as well as C, so that P, Q, R can be calculated, that is the overall order of a reaction. So in that, rate law tells about the rate of a reaction dependency on the concentration of the only reactant. ठीक है बेटा? But does not tell how concentration changes with time. That is very important, noteworthy points. So as you are learning certain things, you need to know what exactly it is and what it should not be. And in this channel, Sri Chaitanya Academy NEET YouTube channel, we are talking about genuine subject, उसमें बकवास नहीं है, and we are not telling all embossing and shouting and colorful events, but genuine subject is given. Take a pen and paper and write noteworthy points. And my dear students, you can ask any academic genuine doubts about the chemical kinetics and all, and whatever the topics you want to know, please mention it. अगले session में हम schedule करके रखना है बेटा. And those who are online, please like this session, share with your friends, and subscribe to this channel, Sri Chaitanya NEET Academy, and we'll just see the other methods here. Moving ahead, integrated rate law. So this method quantitatively gives the concentration of reactant as a function of time. Why? Because if you take A gives rise to B, concentration of A and the time, and the change in the concentration of A with respect to the time is not constant, it is variable. So we have to take as a function of time, and we have to integrate the rate at all times and take all differential things and integrate it. The form of the integrated rate equation depends on the order of a reaction. You have zero order, you have first order, you have a second order. Let us focus on zero order and the first order, and we use the integration concepts here. And integrated rate law for zero order of a reaction and first order of a reaction. देखता हूँ सेकंड ऑर्डर का सिर्फ इक्वेशन देना चाहता हूँ. ठीक है बेटा? And let us talk about first order or zero order. What is the meaning of a zero order reaction? So look at this. Zero order reaction means, let us say rate is equal to K A to the power 0, it is zero order reaction. Rate is equal to K A to the power 1, it is the first order reaction. Rate is equal to K A square, this is a second order reaction. Okay, and in the second order reaction, for a zero order reaction, order is 0, and n value is going to be 0, n is equal to 0. So taki A to the power n is equal to 1, so rate of a reaction for a zero order is equal to rate constant. So rate constant का और स्पेसिफिक रेट कांस्टेंट का जो डायमेंशन होता है ना, ये रेट डायमेंशन का बराबर होता है. दैट इज ऑल्सो वेरी वेरी इंपॉर्टेंट नोटवर्थी पॉइंट्स. CBSE में 1 मार्क क्वेश्चन का आने का संभावना है. एंड व्हाट इज दैट रेट हियर? मोल लीटर इनवर्स एंड सेकेंड इनवर्स. ठीक है, दैट्स वेरी इंपॉर्टेंट. एंड फॉर अ जीरो ऑर्डर रिएक्शन, the rate of reaction is independent on the concentration. If concentration is increased, rate of the reaction is a constant. Okay, so K A per 0 is equal to K, that is minus dA by dt is equal to K. So we write the integrated expression for this. Are you getting or not, bachcho? When you write the integrated constant, when rate is equal to K to the power 0, dA by dt is equal to K. So minus dA is equal to K dt, right? So we are integrating this 0 to time t here. So from A naught to AT here. So when time is equal to 0, concentration A is going to be A naught. A naught indicates initial concentration, bachcho, and initial concentration of A. And when time t is equal and the concentration of A is equal to AT, at this is concentration of A at time t. So putting that in the integration law, so this is integration law, you are going to get A naught minus AT is equal to KT. So K is equal to A naught minus AT by T. AT is equal to A naught minus KT. It is a graph, it is a rate law, integrated rate law expression for zero order. So which indicates a equation of a straight line, y is equal to mx plus c. You are going to see a graph between A and T. You are going to get a straight line with a negative slope for the zero order, and the slope is going to be minus k, and you will be given in the NEET examinations, different graphs will be given. You have to understand which order it is. ये ग्राफ देख के आप बोल सकते हैं, and it is very important. Okay बच्चों, clear? Any doubt, please let me know. If you want, we can take a couple of minutes break also. Fine. And moving ahead here, unit of the rate constant. As I said, rate is equal to K concentration of A to the power n is equal to 0, rate is equal to K. So rate ka constant, so mole, liter inverse and second inverse. So by looking at that, we can say what is the order of a reaction. Simple, very, very, very important, this particular rate constant. Any doubt, bachcho? And here going to be for a zero order, as a time the reactants are consumed completely, that is called time required to complete the reaction. So for a zero order, A naught becomes 0 here at this time for completion. So how to take this time for completion? AT becomes 0, that is going to be A naught by K is equal to time for completion. This is for zero order. First order का मत इस्तेमाल करना, first order का infinity आएगा. First order reaction never be completed. देखते हैं ऐसे, but it will never be completed. Got it? Reaction never takes till completion for first order. Zero order complete कर सकते हैं. Fine beta? Any doubt? And let us talk about a half-life. What is the meaning of a half-life? Half-life is the time required to consume the initial concentration to its half. 50% of the reaction करने के लिए time कितना देर लगेगा? So it means that the reaction is half completed. So at time t is equal to t half, AT is equal to A naught by 2, है ना? Put that A naught by 2 as AT in the zero order kinetics. So T half is equal to A zero order ka K is equal to A naught by A naught minus AT by T. T is equal to A naught minus AT by K. जब AT जो होता है ना A naught by 2 होगा, तब भी A naught by 2 होगा. Yes, this is what is called T half for the zero order. मैं क्या बोलना चाहता हूँ? T half is directly proportional to A naught. That's the reason why you can say T half and the concentration of initial concentration is going to be a straight line passes through the origin. So T half is directly proportional to A naught. समझ में आ रहा है क्या बेटा? Fine. If you have any doubts, please let me know. सुपर ग्राफ्स, फिलहाल कितना ग्राफ्स मिल गया बेटा अनुज को पे? Now we are examples of zero order reactions. याद रखना है क्या? नहीं, but पता करने का मेरा ड्यूटी है. Generally, decomposition of gases on metal surfaces at high concentrations follows zero order reactions. Also, photochemical reactions. Photochemical reactions follows zero order kinetics. Okay, I mean to say Cl2 plus H2 in the presence of UV light 2 gives rise to HCl. This is also zero order reaction. And NH3 decomposed on platinum, any compound decomposed on the metal surface is going to be zero order reaction. AB zero order reversible way. Understand? Clear? Decomposition of Hi on gold, decomposition of ammonia and platinum, and decomposition of PHE3 on nickel. All photochemical reactions are zero order reactions. H2 plus Cl2 gives us 2 HCl. Sub. Okay? And before going for the zero order here, so zero order half life कैसे calculate करो बच्चों? In a zero order reaction, equal concentrations of reactant gets consumed at equal times. That is a noteworthy point. Initially A naught लिया, A naught by 2 होने का T half लगेगा. A naught 2 से 0 बनने के लिए T half लगेगा. Total this is the T completion. सिर्फ 2 half life पे खत्म है. For example, reactant 100 ले, 10 सेकंड के बाद 90 है, 5 सेकंड के बाद 85 है, 2.5 सेकंड के बाद 82.5 है. Okay, it is going like that. This algorithm is important. And moving ahead, zero order reaction, generally in a zero order reaction, replace K by L and K in all previous formulas. Simple. So it is going with T completion and A naught and K. And you can see the first order. Before going for the first order, bachcho, I want to give you just a 5 to 6 minutes break. Okay, and we can continue from here. Is that okay? Stay tuned. Stay tuned. We'll discuss more details about this, right? Start. And I'll write back just 5 minutes. లేకపోతే ఛార్జింగ్ పెట్టాను. Bacho, I am back here and we'll resume the class. So let us talk about the first order kinetics. Most of the reactions that we see in the chemical kinetics in these boards as well as NEET, it is from first order kinetics. Okay, beta? So for a general reaction, the rate is going to be K A to the power n. When n is equal to 1, it is going to be first order reaction. A gives rise to the product. So rate of reaction K A to the power n, and when n is equal to 1, K A hoga, right? So let us see in this graphical version here. So the rate of a reaction and the concentration for the first order reaction, it is going to be a straight line passes through the origin. So rate is equal to Ka. Rate means minus dA by dt is equal to Ka. And we are going to take in the mathematical approach form here. So when time A, concentration is said to be A and the product is said to be 0. When X amount is consumed at the time T, A minus X is left and X is formed, minus dA by dt is equal to Ka, and minus dA minus X by dt is equal to K A minus X hoga, है ना? Right? You can write this first order reaction in two ways. What do you say? Let us integrate here. And in this case, when you take this integration from 0 to time t and concentration A to A naught to AT, and you are going to get integrating in the both sides ln A by A minus X is equal to KT. So that is going to be 2.303 log to the base 10 of A minus A upon A minus X is equal to KT. So K is equal to 2.303 by T log A by A minus X. You are going to use this expression for so many times whenever the first order kinetics comes in the various formats. You can write it. My favorite format is going to be K is equal to 2.303 by T. So log A by A minus X. You can also say this is K is equal to 2.303 by T log A upon A naught. So these are the expressions, and you can use it generously, and direct numericals will be there based on this. And in this first order kinetics, you are going to see 2.303 upon T log A naught by AT is equal to K. So log A naught minus A is equal to KT by 2.303, and log A is equal to constant log A naught minus KT by 2.303, and this gives you an equation between log A is equal to log A naught minus KT by 2.303. I want to say it is going to Y is equal to mx plus T. Equation of straight line. When equation of straight line, when you take log A upon T straight line, and it is going to be first order, and you are going to be minus K by 2.303 is the slope here, you can say. And you are going to see the exponential version of the first order kinetics is going to be A is ln A upon A naught is equal to minus KT. That is going to be A naught exponent KT, and from there you can say A is equal to A naught exponent KT, and that is going to give the C is concentration of A, and the time is going to be the first order kinetics ka ये graph होगा. Understand बच्चों? Clear? Just the graph will be given and you will be writing various questions based on this. If you can recognize the pattern of the graph, you can tell the order of a reaction. And ln A upon A minus x is equal to kT. So putting the values here, half-life, you are going to get T half is equal to 0.693 by K. What do you understand from here? First order reaction, the half-life is independent on the rate concentration. So if you take a graph here, the T half and the concentration, it is going to be a straight line parallel to the concentration axis. This is what is called a first order reaction. Fine. And this is very important, does not depend on the concentration of the reactant. Directly rate constant will be given. You are asked to calculate T half for this. Bacho, are you getting or not? That's fine. Now moving ahead, there is another important parameter, average right. Nuclear chemistry में आप देख चुका है. Right? And there is another important part, average life. T average is equal to reciprocal of the rate constant. K is the rate constant of a reaction. Fine. Good. This is important. Take a note, everybody, if you have any doubts. Anush beta, where are you not asking? Only study. Okay. Moving ahead here, from the first order rate expression, putting the value of A in the equation 3. So time completion for first order reaction, you are going to get infinite time. I want to say here, time required for the first order reaction is infinite. Mean to say, for first order reaction never proceed till completion. Understand? Never proceed till completion. And also, you can see units for the rate constant. Again here, it is going to be second inverse, as we mentioned here. Rate is equal to K concentration. So the concentration mole liter inverse second inverse is the rate, and concentration mole liter inverse K is equal to second inverse. Dono equate karke. By looking at this unit, you can say it is a first order or not. And also, generally for the first order reaction, n number of moles gives rise to a product. Rate is equal to Ka, and minus dA by n dt is equal to K. And in the first order reaction, there are certain things you need to know. And equal percentage of reactants get consumed at equal time. Then you can say reactant 100 become 90 in 5 seconds. And 90 become 81 in 5 seconds, 81 become 72.9 in 5 seconds. Total 15 seconds में 172.9 ही होगा. This is the first time, second half life. Okay, 10% उसमें 81 and 72.9. Even for this half life से आप निकाल सकते. So for example, there are certain examples which we experimentally determined, which we follow for the first order reaction. Decomposition of hydrogen peroxide, okay, radioactive decay. These are the two things we can say. And decomposition of hydrogen peroxide, H2O2 decomposes to gives rise H2O and O2, but the rate expression is given as K and H2O2 to the power 1, okay. And radioactive decay is also follows this. And radioactivity is there in physics, not in chemistry. And also you see here, second order reaction with the खास नहीं है. And just you can go through the graph 1 by A versus T is going to be a straight line intercepting on 1 by A, and this rate expression is going to be, AT is equal to A naught by 2, that is 1 by A minus 1 by A naught is equal to KT. Okay, and half-life is equal to 1 by is directly proportional to 1 by A naught. T half is equal to 1 by K initial concentration for the second order reaction. Second order kinetics CBSE और बोर्ड एग्जामिनेशन में नहीं है, and just expression का ये graphical and expression version is important. Okay, उसमें कुछ numericals derivation के कुछ खास बात नहीं है. Okay, don't have to worry. Please worry about zero order reaction and first order reaction, students. And you see, T half is directly proportional to 1 by A naught, and T half is equal to 1 by A naught means concentration. A straight line passes through the origin. Okay, and this is for the second order reaction. Bacho, units for the rate constant, again we follow the same methodology according to the rate constant. Unit gives us mole inverse liter, and second inverse is the second order, right? And you see, pseudo first order reaction बहुत important बेहतरीन concept है. There are certain reactions which actually follows like a second order, behave like a first order. Pseudo means false. So pseudo first order reaction, the order of a reaction sometimes altered by conditions. Depending upon the condition, a second order reaction can behave as a first order reaction. So the reaction whose order is different from the actual order due to the excess of concentration of the one of the reactants is taken as a pseudo first order reaction. That's a very important concept. Yeah, and pseudo first order reaction, when you say A plus B gives rise to product. So the rate expression is given as K, A to the power 1 and B to the power 1. Order is supposed to be 1 plus 1 is equal to 2, right? It is supposed to be like this. But क्या होता है ना? You can see if the concentration of the reactant, one of the reactant A is taken excess. So excess का हिसाब से rate बदल दे, rate is equal to K, A to the power 1 था, okay, but A to the power 0 बन गया, B to the power 1 बन गया. So that the order is going to be 1. The change in concentration of A is negligible during the reaction, the rate with respect to this. So that is the actual meaning of the pseudo first order reaction. So it can be a constant. Whenever you take something in excess, it behaves like a constant. Now the reactant rate depend on only concentration of B. The reaction behaves like a first order, right? Again I am telling you. So the rate is equal to K, A to the power 1 and B to the power 0. If concentration of A is in excess, so rate is equal to K, A to the power 0 and B to the power 1. That is called pseudo first order reaction. Got it? Very good, my dear doctors. And you can see that's what pseudo first order reaction, the rate that is actually a second order, maybe some other higher order, but behaves as a first order. That is a behavior. So it is said to be pseudo. You all medical students becoming a future doctors, you know what is a pseudo. It's a false. Right, beta? Take thumbs up then. Those who are online, please encourage. And this is a YouTube channel. We are giving you the one-shot marathon sessions. And we are not expecting anything, just applause and a like from your side. Say thumbs up and fire emoji in the class, bachcho. And you can see here example for this. Ester, when it is reacted with water, yes. Ratnapriya or what? Okay, anyways, I can't pronounce your name. So hydrolysis of an ester. Ester is acidic hydrolysis gives rise alcohol and an acid. So time ester 0.01 and excess H2O is taken, and at the time T is reached, the ester ka concentration 0.01 minus X hoga, and you are going to get water concentration 10 minus X hoga. So this 10 minus X जो है ना constant का जैसे दिखता, so that it depends on, you can see the rate is equal to K ester concentration and water concentration to the power 0, because it is taken as 0.01 के compare करने तो 10 ज़्यादा excess number है, isn't it? So that what will happen here, 100 times better, so it is going to be rate expression is going to be ester to the power only. So as the concentration of H2O during the reaction is negligible, 0.01 mole out of 10 mole consumed. Understand? Clear? Fine. And also sucrose, this is another example. It is another example. So hydrolysis of an ester and hydrolysis of sucrose. It is sucrose. Sucrose, it talks hydrolyzes to gives rise glucose and fructose. The rate is equal to K sucrose to the power 1 and water to the power 0. And water to the power 0 है ना तो 1 होगा ना. So it is going to be rate depends on concentration of the sucrose only. And graphs, very important my dear doctors, graphs. So for nth order reaction, rate is equal to K A to the power n. So n is equal to order. So rate concentration, so rate is independent on concentration 0 order. And rate concentration passes through the origin first order. Rate concentration exponential curve second order. Rate concentration square, it is going to be the second order. Understand? This is the behavior of the rates. If you have any doubts, please let me know. And concentration of the reacted versus time for the 0 order. So we'll discuss these graphs in meticulous way. So A concentration versus time, you are going to get a straight line with a negative slope. So this is the intercept is going to be A0 and slope is going to be minus K. And you see for the first order A is equal to A0 exponential minus Kt. Okay, so log A is equal to log A0 minus Kt by 2.303. Here we have 3 graphs. In the graph number 1 hai concentration of A versus time, it is going to be a sigmoid curve. Okay, it is a rectangular hyperbola, and log A upon time, straight line passes through the origin. Log A versus time, here it is log A versus time, it is going to be a straight line down, negative slope. And also for second order 1 by A versus time is going to be a straight line with a positive slope, and intercept is at 1 by A0. Okay, and this is about the graphs. And here T half versus the concentration of the reactant. For 0 order, T half is equal to A0 by 2K. So the T half is directly proportional to A0. So T half and concentration of the A is taken. Straight line passes through the origin, 0 order hoga beta, khatam. And you see here, first order, T half is equal to 0.693 by K. And T half and concentration में independent hai, so that it is going to be a straight line and parallel to the concentration, which indicates T half of the first order reaction independent on the initial concentration. And T half for the second order is equal to 1 by K A naught. So if you take T half and 1 by A naught is going to be a straight line passes through the origin for the second order reaction, right? And this is a very important, very important. Clear? And also unit method. This is another method. It is by looking at the unit, you can just calculate the n value. K is equal to rate upon concentration to the power n. If rate constant का dimension दिया होगा तो you can calculate the n value. So unit of K is equal to mole 1 minus n liter n minus 1 second inverse. So for the first order, for the zero order, for the nth order, any this method of order reaction can be determined. Examination में आप trap में रुकेंगे and you can simply calculate this n value. You can simply calculate this n value. Second inverse, mole liter inverse second inverse, mole inverse liter second inverse second order का, हर ऑर्डर का ये डायमेंशन देख के रेट कांस्टेंट का आपका कौन सा रेट का क्वेश्चन आपको दे चुका, यू कैन सी फ्रॉम देयर. गॉट इट? एनी डाउट? And moving ahead, half-life method. There is another fabulous method. We can calculate the order of a reaction by taking the half-life method. So for a reaction, A gives rise to the product. T half is equal to 1 by initial concentration to the power n minus 1. And from there n value you can calculate. अगर T half दिया होगा तो. So how it is? It is done with various orders here. T half is equal to 1 by A naught n to the power n minus 1. And the different concentration is taken, we can divide it, n can be calculated from the logarithmic version also. So that T half can be calculated, from that n can be calculated. N can be calculated by measuring T half and T half dash as A naught and A naught dash values. Directly you can pick this n value, right? Now let us talk about gaseous reactions and the pressure methods and volume methods and titration methods and optical rotation methods. It is important only for the first order kinetics. Okay. Now as I said, today's class we are talking in terms of only NCRT based, and we talk only about CBSE or whatever the board and NEET examination. In this scenario, my dear doctors, you did a lot of work, hard work throughout the year. Now this is the time where board examination is coming and stopping your NEET exam preparation. But NEET examination only 90 days left, है ना? In these 90 days, 45 days will be with your buffer in the board examination preparation. Your valuable time is being killed. So in this one short session, I am giving you the best out of this, both boards as well as NEET examination जाना है. And let us talk. This is काफ़ी important है बेटा, very important. Titration method and optical rotation method आप बाद में देख सकते हैं. This and this is very important. Are you ready? We'll discuss that. NCRT pressure determination method is given here, bachon. So as we know, we follow when the gaseous reactants and products are there, we follow PV is equal to nRT. Assume this is an ideal behavior. So PV is equal to N by V RT, number of moles per liter is going to be concentration. So the pressure is directly proportional to N by V, and the pressure is directly proportional to N by V means it is a concentration. It is a concentration. So here pressure, volume, number of moles, gas constant, T is the temperature and R is the gas constant. We can say 0.08 to 1 liter atmosphere mole inverse and Kelvin inverse. Okay. And also, so for the reactions involving gaseous reactants in the products, pressure is considered to monitor the reaction instead of the molarity or the whatever the concentration you take. So, as A gives rise to B and C, the reaction progresses, the gaseous reactant products can be monitored by the pressure change method. We connect the reaction mixture with a barometer and we connect with the manometer and measure the total pressure to a fixed volume and the temperature. And here A plus B, A gives rise to B plus C, A minus X and X and X. So, A is the initial concentration, X is the amount consumed, X is the amount formed, X is the amount formed. So, if you take in the pressure, initial pressure A का P naught होगा, reaction फिलहाल चालू किया नहीं, 0 and 0 होगा बेटा. As the time reaches to T, some number of moles, pressure of the gas is directly proportional to number of moles, PV is equal to nRT. So, as number of moles is decreased, so pressure is decreased, decrease in the pressure is equal to increase in the pressure, increase in the pressure. So, P minus P reacted. So, P naught is initial pressure, PR is the pressure due to the amount of reactant consumed up to time T. So, the total pressure कितना होगा डाल्टन्स लॉ का हिसाब से P naught minus PR plus PR plus PR. So, that we can say PT is equal to P naught plus PR. You can say this. Total pressure is collected and calculated. So, you have to use this in terms of first order reaction and put it there. And if you think the pressure measurement method can done by two ways, partial pressure of the reactant, total pressure of the reactant. So, this is what is called as a partial pressure and this is what is called as the total pressure. Partial pressure of the reactant at the time T, this is so valuable, we have to identify from there. And when you take the total pressure, sum of the partial pressures is equal to the total pressure according to Dalton's law of constant pressures. And pressure measurement, so P naught minus PR, PR, total pressure at the time T is equal to PT. And it is going to be P naught minus PR plus PR plus PR, it is going to P naught plus PR. So, PR can be calculated PT minus PR. Put there in the first order kinetics, you can calculate at concentration and the pressure. A become P naught, A minus X become P naught minus PR. A by A minus X is equal to P naught upon P naught minus PR. Put that directly into the first order kinetics equation. What is the first order kinetic equation? Here, first order K T is equal to ln A by A minus X is equal to ln A naught by A. KT is equal to ln P naught by P naught minus PR. That's it. So, you can say substituting these values, KT is equal to ln P naught upon 2 P naught and PT. This is given in the NCERT. Solved question एक है, unsolved questions दो है. So, if you use previous NEET examination, previous CBSE examination, previous JEE examination, based on this, very good number of questions are given. My dear children, please follow this. And you can also see as the reaction progresses, volume measures the same pressure and the volume. So, volume inversely proportional to pressure जब तक temperature constant है. Who said this? Boyle's law का हिसाब से. We apply the Boyle's law, we T0 and pressure is volume is going to be 0 and liquid का जो है ना volume is not considered, just ignore it. And when time t is equal to 0, Vt, when time at infinite it is going to be V infinite. From there you can calculate putting these values and little mathematical manipulation by measuring the volume of the product formed, by monitoring the progress of the reaction, you are going to get Kt is equal to ln A by A minus x. So put that initial volume at time t and volume infinity, you are going to get this. A is the amount of solid taken initially, so it is given as a solid, liquid and a gas. So volume of a gas collected at infinite time is V infinity, amount of the solid decomposed is going to be V minus x, and the volume of the gas collected at time t is equal to Vt. Put that in direct way. So A minus x is going to be V infinity minus Vt, and putting that Kt is equal to ln V infinity minus Vt. Just directly you can take this. Fine. So you can say K is equal to 2.303 by T and V infinity by, so V infinity minus Vt. So titrometric methods and all, which is not actually required right now, and we'll move little beyond that. Yes. Now share का है molecularity of the reaction. Molecularity of the reaction. You have two types of reactions. One is elementary reaction, another one is complex reaction. Elementary reaction जो है एक ही step में चलता, that is called elementary reaction, and complex reaction is the reaction which takes place in multiple steps. So the number of reacting species, वो reacting species atoms होगा, ions होगा, molecules होगा, anything taking part in one elementary reaction. So which must make a collision. Actually a reaction takes place when the reactant molecule make a collision. So in elementary step कितना molecule आके collision कर रहे हैं, that is called molecularity. So molecularity can be 1, molecularity can be 2, molecularity can be 3. Molecularity cannot be 0, molecularity cannot be 3. If you want to say it's a molecularity can be 3, practically it is not possible to imagine 4 molecules at a time come and make a collision. So that, dear doctors, this is not possible. So let us see, it is a theoretical concept better. So elementary reaction involves more than 3 molecules are not known. So the molecularity can never be greater than 3. Right? So let's see the difference between the order and the molecularity. Now confusion comes. फिलहाल order देख चुका and molecularity new guest आए. Who is that? So rate is defined as the sum of the powers of the concentration terms that appear in the rate law. Rate law का हिसाब से order निकालना. Okay? And it may be equal to 0, negative, fractional, integer, anything. But molecularity is defined as the number of reacting species that taking part in an elementary step. It is always a whole number. It neither can be a 0 nor be fractional nor be greater than 3. Okay? Fine. Now, it is defined only for elementary reactions, but order of a reaction elementary as well as complex के भी दे सकता, overall order के देना पड़ता. And molecularity is actually theoretical value. By looking at that mechanism, by looking at that balance of the chemical equation, you can say. But order of a reaction experiment का हिसाब से देना पड़ता है बेटा. Any doubt? And board के साथ NEET examination preparation जा रहा है यहाँ पर, and board examination में ये differences आने का संभावना है. And NEET में कैसे? Which of the following is true? Which of the following is not true? How many of the following statements are true? Right? Anush, hope you understand. Statement based questions you are only saying. In JEE examination काफी बार पूछा, and we need to understand which of the following is true as well, right? Which of the following is not true? Understood? Everybody take a screenshot of this. Board examination में काम आ जाएगा आपको. taken 3, 2, 1, and और एक चीज है taken 3, 2, 1. And moving ahead, here types of reactions. As I mentioned, it is two types: elementary reaction and complex and multi-step reaction. देखो, elementary reaction, these are the simple step reactions. This takes place in a single step and without the formation of an intermediate. So intermediate formed during the course of reaction but not present in the overall balanced reaction. I want to tell you two things here. One is an intermediate, another one is a transition state. When it comes to a reaction, reactant, it is going to give you product. So what is there in the reactant? Its old bonds are present. During the course of reactant, new bonds or product are established. So there is a situation where the old bonds are completely broken and new bonds are not yet formed. That is called intermediate. Before forming that intermediate, you are going to get a transition state 1 and a transition state 2. ये transition state होता है क्या? A transition state is the one where the old bonds are not completely broken, and the transition 2 is where the new bonds are not completely established. This is about the total mechanism of the reaction. Let it be it is an inorganic chemistry and the organic chemistry. लेकिन organic chemistry में काफ़ी important है. So H2 plus I2 gives us 2HA. The rate is given as a KH2 and I2. This is a simple one-step reaction, elementary reaction we discussed. In the elementary reaction, AB plus C gives rise AC plus B. So there is a transition state, the state corresponding to the highest potential energy. When you draw a graph between potential energy and the reaction coordinate, my dear doctors, and reactant का energy कम से कम होगा, when they make a collision, they are going to get highest state, and this is the energy of the products. You know, this is the difference in the energy that is called enthalpy of reaction. And you know, ये जो reactant का ये threshold energy बनाने के लिए आप बाहर से कुछ energy इसका देना है, that is what is called as activation energy. ठीक है? And this activation energy depends on various reaction conditions and the reaction and reaction rates. And you can see here, for elementary reaction, A moles of A plus B moles of B gives rise to the product. And molecularity, this type of reaction is equal to order. So for elementary reaction, molecularity is equal to order. For complex reaction ऐसा नहीं होगा बेटा, right? कैसा होता है देखो, so for complex reaction, the reaction that proceeds in more than 2 steps follows the mechanism, and 2NO plus H2 gives us N2 plus 2H2O, 2NO, N2O2, N2O2, H2. So step 1, step 2, step 3. So we are already seen this. The sequence of just converts the reactant to the products, and उसमें ये step 1, step 2 and step 3 वो overall reaction का है. There is one reaction where it takes slowly, that is called slowest step, and it is called as rate determining step. And in that you can say, in the complex reaction, as it consists of multiple steps, every step behaves as an elementary step, है ना? And each step has its own molecularity. Each step has its own molecularity. But order is written according to the rate law. The rate law depends upon the slowest step. So A gives rise intermediate, 2 gives rise the product. And this is an intermediate का बेटा, intermediate का. हर एक intermediate का 2 transition states होगा. this is a transition state 1 and this is a transition state 2. When transition state 1 means the old bonds are not completely broken, so highest energy, because that bonding complex is going to be destabilized. The moment it is broken, all the factors, let us say a carbocation, all the factors that stabilize carbocation, immediately resonance, hyperconjugation, positive inductive effect, all people will come and make it stable, so that इसका energy थोड़ा सा कमी आने का कोशिश करता. Intermediate will have the less energy as compared to transition state. हर एक intermediate का 2 transition state होगा. Okay, and number of steps depends on number of intermediates. Okay, and it is going to give the product finally. This is the way you need to study chemical reaction. So as I said, what is chemistry? Chemistry is study of chemical reaction at atomic level, molecular level and bonding level, isn't it? Yes. Now you can say rate determining step क्या होगा? I have given you 2 pictures, here and here, right? Let us say the rate of flow of sand is decided only by the narrow opening. This is the narrow opening. Similarly, the rate of reaction decided by the slowest step. है ना? So narrow opening from here to here and आने के वक्त में this is the point. It can stop the reaction and regulate the flow. This is not the flow, this is not the flow, this is the step 1, step 2, step 3 and final step. Okay, and large opening and narrow opening decides it, isn't it? It is a narrow opening, largest opening. You see different levels of openings are there. Jubair, salam alaikum. Now let us see one more picture here. If you say a large opening and a large opening, उसमें बीच में a narrow opening here. This is a step 2 in this flow. This is the step 2 is the rate determining step, isn't it? The rate of flow sand is decided by the narrow opening only. You correlate this in chemical kinetics, isn't it? And similarly, you can say the order of any reaction is complex has to be always determined experimentally. This is the universal fact. उसमें कुछ bargain नहीं है, non-negotiable. So the step of a complex reaction, that is the slowest and the which overall reaction rate is determined, right? So उसमें generally for a chemical reaction temperature का dependency क्या होगा? For every 10 degrees raise in the temperature, rate of reaction usually doubles or triples. So effect of temperature of the rate of reaction can be mathematically determined by temperature coefficient. That's very, very, very important. Most of the reactions we need to activate the reactant. So as the temperature is increased, the rate of reaction generally increases. Let it be exothermic or endothermic. Once the reaction is proceeding, if it is exothermic, ली चार्ट लेयर प्रिंसिपल के हिसाब से अगर टेम्परेचर बढ़ते जाता है रिएक्शन में reverse it back, but to initiate and start the reaction temperature is mostly required. And you can see the ratio of the rate constant of at temperature, two different temperatures differed by 10 degrees centigrade is called as a temperature coefficient. It is indicated by a symbol called mu. Okay, that is rate constant at T degree centigrade plus 10 upon rate constant K, and generally it could be either 2 or 3. In most of the cases it is 2. Understand? Clear? And you can say Arrhenius theory. It is also very important. Just I want to give you a little introduction about the temperature dependent of a rate of a chemical reaction can be accurately explained by Arrhenius theory. So the relation between the temperature and the rate constant is given as K, A exponent minus EA by RT. What is that K? This is called K rate constant, and A Arrhenius factor or a frequency factor or a pre-exponential factor, and EA is activation energy, the extra energy that is supplied to the reactant to reach the threshold energy value or limiting energy value is called as activation energy, and R is the gas constant. जब आप गैस कांस्टेंट इस्तेमाल कर रहे हैं ना 8.314 जॉल केल्विन इनवर्स मोल इनवर्स इस्तेमाल करो बेटा, ओके, एंड T is the temperature, right? This is called Arrhenius equation, and based on this Arrhenius equation we can do so many analytical approaches. Let us see here. So elementary reaction for Arrhenius theory according to A2B2 gives us 2AB. Dear children, you can see according to transition state theory the reaction can take place between these two molecules when a proper collision takes place, है ना? ये proper collision होता है क्या? So that is given as a collision theory. A collision leads to the unstable state because when two molecules are making a collision, the bonds in that molecule are detached, so that ये नया बॉन्ड बनाने के वक्त में ये प्रोडक्ट बनेगा. Dear children, so it exists for very short time. That collision exists in a very, very, very short time, and gradually products are formed in this. And this is called transition state complex activation complex. Reactant gives rise a product. When reactant molecule makes a collision, activated complex is formed. And does every collision, you see, when A and B is making a collision, so it is going to form a transition complex. So the bond is still there, the bond is still not completely formed. The moment the bond is completely detached and a new product is formed. Fine. When the new bond is formed, energy required to form an activated complex is called activation energy. It is given as EA, and that activation energy, you see, it is a reactant, and when you give the energy to make an activated complex and the energy you want to give, that is called as an activation energy, and a product is formed. And the difference between the activation energy and the product is going to be enthalpy of a reaction. It could be exothermic or it could be endothermic. Bachcho, if it is given like this and if it is given like this, okay, it is exo, delta H is going to be negative, and it is endothermic, delta H is going to be positive. It all depends upon like this. Fine. Those students, please understand. If you have any doubts, please let me know here. For exothermic का ये ग्राफ ऐसे आना है, right? Endothermic का ग्राफ ऐसे आना है, and enthalpy of reaction, standard enthalpy of reaction is equal to sum of the enthalpy of products minus sum of the enthalpy of reactants. Okay, it should be greater than 0, and it is for reactant gives rise to product. This is enthalpy of reaction, and this is what is called activation energy for the forward reaction. If you want to go for the reverse reaction ना, you have to give the product to this transition state. Transition state वही रहेगा. Understand? And activation energy for the backward reaction. So we are connected here. Thermodynamics, this particular state we are connected chemical kinetics, thermodynamics, and forward and backward means equilibrium. So the physical aspect of the reaction depends on all these three. People say Whenever numericals comes, this is not physical chemistry, right? Physical chemistry means chemical kinetics and thermodynamics and equilibrium, right, bachon? Now we'll extend further discussion about this activated complex and Arrhenius mathematical equation in next session. As the time is almost exhausted, we'll meet with more stuff in the next class. So Arrhenius equation का एक short video बना के आपको देना चाहता हूँ, एक long shot and numericals भी बना के एक देना चाहता हूँ. So next session we'll meet with numericals of the chemical kinetics and Arrhenius equation. Okay, dear children, now hope you all understood today's session and hope you enjoyed this session. A marathon session is more than 2 hours, and please like this session, share with your friends, subscribe to Sri Chaitanya Infinity Lane NEET YouTube channel, and please post any doubts in this session. Please let me know. Thank you very much. Signing off, Dr. Suresh, Faculty of Chemistry. Thank you. Thank you very much.